All right, we're now on the back. Distance in a specific direction. Any guesses?
Velocity?
No. That's going to be speed in a certain direction. Distance in a certain direction.
Acceleration?
Nope. That's your displacement again. Yeah. It doesn't really tell you that straight out in the lesson. Okay. But if I say displacement is like distance, but with a direction specified. If I just say like 100 meters, that's just a distance. If I say 100 meters towards the stadium, that's displacement. Okay, speed with a direction, again, is velocity. Very good. Okay, now we need to understand the difference between something called vector quantities and scalar quantities. And your book doesn't even really talk about scalar quantities much at all, I don't think. Vector quantities have to have two things. What are they? Yep. Both a size and a direction. Good. The direction matters. Scalar quantities, on the other hand, are fully described by size only. Okay? Sometimes instead of size, I may use the word magnitude, but that's just a fancy word for like how big. Okay? Okay. So if you got far enough in your lesson yesterday, you may have written down some examples of vector quantities. Things that have to have a direction. Give me some examples. Good. Displacement's one of them. Displacement. Somebody said force. Somebody else said velocity. Some other ones. Momentum. We don't really do momentum in here. But momentum is like mass and velocity together. What else? Acceleration is a vector quantity. It matters which way it's oriented. Weight. Which way is weight always oriented? Straight down towards the center of the earth, because it's weight. It's the earth pulling on you, right? Okay. Okay, so those are vector quantities. Give me some examples. Try to think of some things that are scalar quantities that don't have to have a direction. Do what? Time. Very good.
Good job.
Other things that don't have to have a direction. Distance. Good, because is there a difference between distance and displacement? Yes. Distance in a certain direction is displacement. Ooh, kind of like velocity. Velocity is something with a certain direction. Velocity is speed in a certain direction. So if I just say speed, that's a scalar quantity. Speed in a specific direction, and that's velocity. Other things that are scalar quantities would be things like mass, volume, stuff that you can measure, but it's not important to have a direction. Does that make sense to you guys? Okay. All right. Let's go down to the bottom. Okay. Hopefully you got to this point in your screencasts, because this was written, I think, on page 180. Acceleration describes a change in what? Velocity over time. And objects accelerate if they change their velocity. And there's three ways that you can change an object's velocity, because velocity is both speed and direction. So objects accelerate if they Speed up, slow down, or change direction, or they can do more than one of them at the same time. Obviously, they can't speed up and slow down at the same time, but could you speed up and change direction at the same time? Could you slow down and change direction at the same time? Could you be accelerating if you are only changing direction? Yes, because it's one of the things that qualifies as acceleration. Okay, so I'm going to pause this while I write that down. Okay, so speeding up, slowing down, or changing direction. And then on page 183, gives you your formula for average acceleration. Average acceleration, how do we calculate that? Final velocity minus starting velocity divided by change in time. Good. No, that was not hard at all. Final velocity minus initial velocity divided by time. Okay, guys, on the lesson, I also gave you this. A equals, and it's got a triangle V divided by triangle T. Do y'all see that? Yes. This triangle, write this down on your Bellwork. That is a substitute for the words change in. You'll see that a lot if you take any fancy-dancy science classes later on. Okay, so if I put, and the triangle is actually a Greek symbol, delta. If I put change in velocity divided by change in time, I can just write it triangle V divided by triangle T. Does that make sense to you guys? That's just shorthand. It's an abbreviation. It's a way for me to write it quicker. Okay, so how do I get the change in velocity? Well, I do final velocity minus initial velocity. How do I get the change in time? I get final time minus initial time. A lot of times the beginning time is just 0, but is everybody okay with that? Okay, so I'm going to zoom out so that those listening to the recording can actually see everything. Okay, so for the benefit of those of you having to do this from the video, I have everything filled out. Make sure that you've got everything that we've just talked about. Pause your video if you need to in order to write down anything that you missed. Okay? Alrighty.